Exercise 8.1, sum number 6. Prove that the line segments joining the midpoints of the adjacent sides of the quadrilateral form a parallelogram. Right? So what we need to prove means we have one quadrilateral. This is one quadrilateral. In this quadrilateral, joining the midpoint of the adjacent sides. For example, one quadrilateral we drawn means we joining the midpoints here on midpoint, here on midpoint, like this. We join means we are getting one parallelogram, right? We have to take one quadrilateral. We take the midpoint of the sides of the quadrilateral. AB is one side, BC is another side, CD is one side, and AD is one side. From these four sides, we need to take midpoint for each side. So joining these midpoints, we are getting one parallelogram. This is like square, right? In this small diagram, we are we are getting one parallelogram like this, but no problem. Only we need to prove, that's all, right? So we are getting one parallelogram, right? So what is given? Proof. Let A be a quadrilateral. The given is ABCD is a quadrilateral, and PQRS be the midpoint of the sides of PQRS be the midpoint of the sides of for AB is P, BC is Q, CD is R, and AD is S. That is I written here. Then the position vector of PQRS. Position vector of PQRS. That is, here we need to mention A vector, B vector, C vector, D vector, because the given position vectors. So here capital A in here, this is called what? A vector, because these vertices are joining from any other origin. Some other origin is there in background, right? So these A, B, C, D are position vectors. So P vector we take means this is what? Midpoint. P is the midpoint of AB. We know the midpoint formula. P vector equal to OP vector equal to A vector plus B vector by 2. So then the position vectors of PQRS for P, we take the midpoint means A vector plus B vector by 2. This is for P. Suppose you are written OP vector means what? A vector plus B vector by 2. Q is A vector, B vector plus C vector by 2 midpoint, because B as Q is the midpoint of BC for that reason. Clear? So Q equal to B vector plus C vector by 2, and then R, C vector plus D vector by 2. And S vector equal to A vector plus D vector by 2. A vector plus D vector by 2. Right? So like this we need to form the sentence. Right? Once I say, let A, B, C, D be a quadrilateral given in the question. In that quadrilateral, we need to have the midpoints. PQRS be the midpoint of the sides AB, BC, CD and DA. Then the position vectors of PQRS are A vector plus B vector by 2. For this P, this one. For this Q, this one. For this R, yes. Then, in order to prove, what we need to prove? We join the midpoints, we are getting a parallelogram. So, in order to prove that PQRS is a parallelogram, it is sufficient to prove that PQ vector equal to SR vector, because in parallelogram, for example, this is one parallelogram we taken means these opposite sides are equal, these opposite sides are parallel or equal. Then these opposite sides are double line. Opposite sides are parallel. This is a property for the parallelogram. So here I taken PQRS means PQ is equal to SR. QR is equal to PS or PQ is parallel to SR. Both the meaning will be same. Clear? Right. So what we need to prove? PQ vector equal to SR vector. This vector equal to this vector. Then PS. This PS. This side, two side, opposites are equal or parallel. Right? So what I do here? PQ vector equal to SR vector. So PQ vector equal to position vector of Q minus position vector of P, because PQ vector equal to OQ vector minus OP vector, right? That one I written position vector of Q minus position vector of P, because position vector is what? From the origin, right? So OQ vector minus OP vector, both are same, right? This equal to position vector of Q equal to what? For Q, B vector plus C vector by 2, B vector plus C vector by 2 minus position vector of P, A vector plus B vector by 2, A vector plus B vector by 2. This minus is common for both B vector plus C vector minus A vector minus B vector by 2. Minus B plus B. So finally we are getting C vector minus A vector by 2. This is the answer for PQ vector. Clear? Now we need to prove what? PQ vector equal to SR vector. Right? So SR vector, position vector of R minus position vector of S. That is OR minus OS vector. OR is what? R vector equal to what? R. R means C vector plus D vector by 2. C vector plus D vector by 2 minus S equal to A vector plus D vector by 2. A vector plus D vector by 2. This equal to C vector plus D vector. We take minus inside means minus A vector minus D vector by 2. Minus D plus D will be cancelled, means what we are getting? C vector minus D vector or C vector minus D vector by 2. This is 1. This is 2 I take, means from 1 and 2. From 1 and 2. PQ for answer C vector minus A vector by 2. SR answer C vector minus D vector by 2. So PQ vector is parallel to SR vector, right? So PQ vector is equal to SR vector. Similarly, three lines I put LY. This is shortcut for similarly. Similarly, we can prove that PS vector is equal to QR vector. Right? Hence, proved. Clear? So like this, you need to prove this sum. Thank you.